Okay, so everything is fine now. So in last class, we discussed about gasoline direct injection, GDI, in which we have discussed very briefly that what is the gasoline direct injections, why we need GDI technology, what are the merits and limitations of the GDI. In a very briefly, we have discussed it. That's fine. And then we started about CI engine fuel injection system. So before starting off the hardware that is being used in the CI engine, we first of all discussed about that what happens when the fuel is in, once the fuel comes out from the injector, and then before it goes to the combustion, then what are the different physical process or essential process takes place. So the first of all, the fuel is being injected at very high pressure through the small orifice of fuel injector. And since the fuel is injected at a very high pressure through the very small orifice, then it will go to the atomization process. That is nothing but the fuel is liquid fuel is going to be disintegrate into the small droplets. And this atomization is very, very important part of the diesel engine combustion. Because we want to have optimized as small as possible so that it can evaporate very fast and it mix with the air. Okay. So once fuel is going to be atomized, then since it has been injected at very high pressure, uh, the fuel droplets is going to be penetrate across the combustion chamber depending upon its momentum. And penetrations, how far the fuel droplet is going inside the combustion chamber, it is also a optimizing factor. Neither it should be under penetrations or over penetrations. If the fuel droplet cannot travel deeper inside the combustion chamber, then we will not be in the positions to utilize the air. And then what will happen then some of the combustion chamber, part of the combustion chamber may not have a fuel concentrations, or there will be a very fuel mixtures. If the momentum of the small droplets is such that it has a too high and it can hit even the liner, then there is another problem, because then your fuel droplets is going to interact with the lubricating oil that is present on the liner. And then since lubricating oil is a very long chain of carbon particles, carbon atoms, and it's very difficult to have a complete combustion of such kind of the things, then what will happen? Then it will again a source of the emission. So the penetrations has to be in optimized manner, that neither it should be underutilizations of the air, or neither it should hit on the liner surface. So once the fuel is optimized and it travel across the combustion chamber, then what happens? Then fuel droplets will absorb the heat and it can vaporize. And then once it is vaporized, then it mixes with the air and the forms a combustible mixture. Once the thermodynamic conditions of the part of the combustion chamber is suitable or conducive enough means it has a preset temperature and the air fuel mixing within the combustible range, then the combustion is going to be start. That is what is the fuel has to go under this process before the combustions start. So atomization, penetration, fuel vaporizations, mixing with air, and then it's a combustion. Okay. Now let us move to another part. When we discussed where we will discuss about diesel engine combustion or diesel engine emission. You will see that most of these phenomena is possible to somehow correlate with the spray characterization. What does it mean, spray characterization? That once the fuel is injected through the injected through the injector at very high pressure, then jet will come out through the jets through the small orifice. OK, so if you see the typical structure of the fuel jet, there are several parameters associated with that. And based on that, we define that what would be the value of the different parameters. Like what are the different parameters? That one of them that is written here, like a spray angle, breakup length, a spray tip penetration, and droplet size distributions. These are the typical characterizations of the parameters of the spray. And based on that, it is possible to it is possible to explain most of the phenomena of the combustion or the emission. So when you design a fuel injection system, we have to find it out that what is the spray angle, what is the breakup length, how far the fuel is traveling across the combustion chamber depending upon the back environment, and what is the droplet size distribution. So these are the very important spray parameters that is needs to be defined for a given fuel injection system and the fuel and the injection pressure. But for a given engine where the fuel and the hardware is the fixed, okay, then all these parameters is going to be depend on the mostly on the mainly it's going to be depend on the fuel injection pressure. Currently, what we are seeing just one jet here. Yeah, now at least all of you have done one lab, first lab of the IC engine, the IC engine lab, in which we have seen the injector of the diesel engine. And then at that time, I explained that there are different kind of the injector. One of injector is like it has only one hole through which the fuels comes out, and then therefore it's called single jet injector. However, in the multi-cylinder engine or in the passenger cars, whatever we see, most of the injector is multi-hole injector. Multi-hole injector, it means on the periphery of the tip of the injector, there are several holes. There's not only one hole, there's several holes. Several holes, it means I can say that is a 6-hole injector or 8-hole injector. So there are 8 different jets or 6 different jets will come out from the fuel from the tip of the injector, and it will go in the different directions of the combustion in the different directions. So yes, so now let us come back here. The spray characterization. So whenever the fuel comes out from the injector, if you see, then it forms a very much similar to the conical shape. So what is the spray angle? What is the cone angle or the angle between these two extreme lines? That we called it a spray angle. This spray angle is mainly very important. If it is a narrow spray angle, okay, then what will happen? There are less entrainment of the air inside the jet is going to be takes place. If it is a larger angle, then more air can be entrained into the spray and forms the air-fuel mixture. But it also depends upon the geometry of the combustion chamber and how many jets. That if there are 8 or 10 or 12, however, I haven't seen 10, but 8 is very common or 6 is very common fuel engine is a very common jet. So suppose and the There might be possible that cone and spray angle is too large, then the two sprays itself are going to interact with each other or interfere with each other. That is also not going to be the conducive situations. So a spray angle is also has to be defined or dependent on the different parameters so that we can more air can trend into the jet and forms the air fuel mixture. Then another parameter is called a spray breakup length. That is what you can see here. That is a spray breakup length. What is that? Is that this is your tip. Okay. So when the fuel comes out from the jet, then immediately it is not possible that fuel can can disintegrate into the small droplets or fuel atomization can take place. There is a certain distance in which the fuel remains in the liquid in the continuous liquid phase. So the distance between the point at which the fuel is going into the disintegration process from the tip of the injector, that distance is called breakup length. So in the breakup length, essentially the fuel remains in the continuous liquid phase. Okay, and after that it goes to the atomization process. That is called breakup length. So our aim is to minimize the breakup length as much as possible so that the atomization process can initiate at a very shorter distance from the jet tip itself. Spray tip penetration. Spray tip penetrations that the farthest distance from the tip of the injector at which the fuel droplets can travel inside the combustion chamber. So that farthest distance, a distance through which the fuel droplet has traveled into the combustion chamber, that is defined as the spray tip penetration. As I told you that neither it should be the under penetrations, neither it should be the over penetrations. Both have a demerits. So the fuel must travel at the optimum distance so that the fuel distributions can take place more or less uniformly into the combustion chamber. Droplet size distribution. So when the atomization takes place, when fuel is going to be disintegrated into the small droplets, then what is the droplet size? Okay, what is the droplet size at the different cross sections of the jet, or even at the one cross sectional area? How the droplet size is varying with varying the radial distance from the axis of the jet. So all these phenomena we can find it out here in the droplet size distribution. If you remember, I told that during our PFI conditions, where we are injecting the fuel at the very low pressure, like 3 to 5 bar, and at that time I told that the droplet size at this fuel injection pressure is approximately 120 micrometer. Here what we are talking about in the CRDI systems where the fuel injection pressure is very high, it means it may go up to the 1500, 1800 or 2000 bar. So the fuel droplet size is very small in case of the diesel engine because we need to have droplet size as small as possible so that the evaporation process starts immediately. So mostly the droplet size in the diesel engine with this such kind of the system is around 30 to you can say 25 to 40 micrometer. So this spray angle, breakup length, spray tip penetration, droplet size parameters, these are the important or main parameter of the spray through which you can characterize it. Okay. Now, the very important is that how we are going to measure all these 4 parameters. Okay. So spray angle or spray tip penetration, even breakup length. First of all, if you want to do the real measurement, it means the injector is installed in the engine. OK, and then you want to measure all these parameters inside the engine in the realistic conditions. It requires a very sophisticated kind of the setup. You need a optical engine. I have introduced the concept of the optical engine during the beginning of our class, in which the up part of the liner and the piston has a uh, optical SS, and even there is a extended connecting rod is also there. So we need to have optical engine, and then we need to have some sophisticated laser based diagnostics tool, and then we can do the all sort of the characterizations or measurements of these parameters in the realistic conditions. Even in the realistic condition, we have a such kind of the system, then measurement and methodology is really very challenging. So alternatively, what people do, there are two different ways to do that. One is that just into the injections in the atmospheric conditions. That is very idealistic kind of the characterization and far away from the realistic condition. When you are injecting the fuel in the just atmospheric conditions. Why I'm saying it is far away from the realistic conditions? Because the environment in which it is injected, it is far away from the realistic conditions. The outside environment, if you are injecting in the atmosphere, it is what it is just like an atmospheric condition. But in the realistic conditions, the fuel injection takes place towards the end of the compression stroke, where the pressure and temperature is very high. It has a definite motions, turbulence, all sort of the things. Everything is the absent, but this is the simplest way to do this kind of the measurement. And at least we can get some kind of the information. So if you are injecting the fuel injection system in the atmospheric conditions, so you don't need to go into engine. You can do all sort of the measurement in the offline condition, offline mode. Offline mode, it means you just need to have an injector and then actuation system separately and the fuel injection system separately also. So we don't need any sort of the engine, and then inject the fuel outside the in the atmosphere condition. Then if you are, it means you can see the jet. So all these parameters, it can be possible to get it with high speed photography. If we can capture or you can take the image at very high speed, then after taking the image, if you can do the image analysis, you can find it out the spray angle, spray breakup length, and spray tip penetration. At these two parameters is very easy to get with the high speed photography. How about the droplet size distributions? If you want to do the droplet size distributions also, then we need another equipment, and it's sophisticated equipment that is called phase Doppler particle analysis. Phase Doppler particle analysis, PDPA. That if with the help, it is a laser based equipment, okay, and based on that it measures the droplet size, droplet size distributions, droplet distributions, as velocity distributions, all sort of the parameters. It's very good. PDP is very good kind of the equipment that can very helpful in order to characterize the spray. So all these parameters, so these three can be done with the high speed photography, and the droplet size distributions we can do it with the help of the PDPA droplet phase Doppler particle analyzer equipment. Once we want to go even closer to the realistic conditions, okay, so what people do, they they inject the fuel into the constant volume combustion chamber. What does it mean? The constant volume combustion chamber is in very simple way. You can assume it is just an enclosed surface. OK, the shape may be the anything like a square, you can say, or rectangular, you can say, or any kind of the shape. Only thing is that constant volume combustion chamber has a has a optical access. So from the outside, we can look inside the constant volume combustion chamber. OK, and then it has a strength. It can withstand the temperature, and it can it can extend the high pressure, and we can heat it up also. So we fill the constant volume combustion chamber either with the air or even with the nitrogen, non-combusting medium. And at the desired pressure at which the fuel injection actually takes place in the engine, and even we can heat it up. So the pressure and temperature we can simulate in the constant volume combustion chamber. But still there what it will be absent on the constant volume combustion chamber, that is the turbulence or the air movement. That is okay, that is acceptable up to that point. Generally, air we don't use in the asperic characterizations, because if you raise the pressure and temperature in the constant volume combustion chamber at a very high level and then you can inject, then what will happen? Immediately it is going to combustion takes place. So you cannot find it out all the sort of the parameters. So therefore we use the non-reacting medium or non-combusting medium, so that we can, without the combustions, we can do all sort of the characterizations. So the in the constant volume combustion chamber, in the high speed photography and the PDPA equipment setup, we are very much in conditions to do the experiments, measure these all four parameters in a very close to the realistic conditions. OK, so this is very important parameters in the diesel engine, and people gives a lot of attention in developing to the injection system and find it out what are the spray parameters, because slight variations in the parameters is going to affect in a very different way of your performance and the emissions of the diesel engine. So now let us discuss about the hardware. I would say whenever you are walking in our academic area or in the campus, just look any car very carefully from the outside. Don't touch it, don't open it. OK. There are so many abbreviations are written on the body of the car itself. If you go to the back side or any side view, it may be written VVT, CRDI. OK, some stickers are also stick there, that is written BS6, BS4, all sort of there's just so many things are written there. So these are the really very important abbreviations that you can read from the outside and try to understand that what does it mean. All of the diesel engine as of now, let us take our example in a very small zone like our campus itself. All of the car, all the diesel car, whatever you can see in our campus, look very carefully. There might be written CRDI or CRDE or something like that. It means this engine is equipped with a fuel injection technology that is called Common Rail Direct Injection. Common Rail Direct Injection, CRDI. So this is the name of the fuel injection systems that nowadays all of your diesel engine is equipped with that. OK, Common Rail Direct Injection System. This is the latest technology we have in the diesel engine, through which the fuel injection takes place, and it has a lot of flexibility. this system, this technology has changed the face of the diesel engine. If I remember correctly, in India at least, the first version of the Scorpio, okay, the first version of Scorpio is just something around 2005 or 2006. 2006. They claim that this is our first CRDI systems in India. The first version of the your Scorpio. Now, what is the why I'm giving so much emphasis and giving so many good things about the common L direct injection system? Because initially, before that, whatever we had fuel injection system, that is the mechanical fuel injection system. And as sometimes I explain to you that with the help of the mechanical fuel injection systems, if the system is mechanical fuel injection system, there are so many limitations. Limitations in terms of the fuel injection pressure. There, the maximum fuel injection pressure that we can get it is around 280 or 300 bar max. Okay. Now we can compare. Okay. That is the maximum fuel injection pressure, but that for CRDI systems, probably this is the minimum fuel injection system, or this is what we can start from here. Then there's a lot of constraints about in changing the fuel injection timing or quantity. Obviously, these are with the different operating conditions of the engine. There is no such kind of the flexibility we had with the mechanical fuel injection system. But over the time, when there is a lot of development takes place in the technology, or most important in the manufacturing sector, because these are injectors has a highly precise is a fine example of the modern manufacturing system. So with the advent of the technology and the precise manufacturing systems, now the common L direct injection systems comes into the market. However, we cannot say that it is very new, because these systems are sort of this technology is very older in terms we can say it is even in the 8085 it was existed, but in a very different way. But over the time, there's a lot of the flexibility has been added, and nowadays it's very good technology. So let us see. So one thing is very clear nowadays, all of the diesel engine passenger cars or advanced bus or anything, the fuel injection system in the diesel engine is common rail direct injection system. Okay, so at least that has to be very clear to all of you. Now, how the CRDI system works, what are the different different hardwares are there that we need to understand very clearly. Now see this picture very carefully. This is your fuel filter. The fuel is coming from the fuel tank. Okay, in fuel tank there will be a small pressure. There is a small pump that will pressurize the fuel, so that the fuel from the fuel tank it will reach to the high pressure fuel pump here. But before that, it will go through the filtration system, so that all sort of the small particles and everything can be filtered out at this point, because even a small particles, it is enough to create a problem in the fuel pump and the fuel injector. Even it can go to the clocking also. So we have a fuel injector, fuel filter here. It will pass through the very fine filter systems, and filter is also very advanced filter nowadays. We have a sensor here. Suppose if the filtering system is going to be overloaded, okay, and then the flow rate is going to be compromised, then there is a sensor and it will give you the signals to the ECU, or it will indicate some sort of the indications to the DAX board that you need to change the fuel pump or fuel filter. Then after the fuel filter, it will come to this pump. This is the heart of the common rail direct injection system. It is a high pressure fuel pump. It is representing the high pressure fuel pump. it is a and then here the pump is going to compress the fuel at very high pressure. And then what will happen? Then high pressure fuel, that is, you can see from here it is coming out and it is going to this pipe. This is a kind of the cylindrical pipe, okay, and we name it as a rail. Rail, it is a similar kind of the rail that we have also used this a name nomenclature in the PFI also. Your rail is going to act as a reservoir of the high pressure fuel. And then from the rail, your high pressure line is connected, and that another end of this pipe is going to connect with the injector. In the mechanical fuel injection systems, as you have seen in the lab, this high pressure line that is connecting to the rail to the injector, in fact it is connected to the pump itself. So there was no such kind of the intermediate part that is called a rail in the mechanical fuel injection system. This injector is directly connected to the pump. But in the common rail direct injection system, it is not like that. Here we are using an intermediate system, that is rail, in which the high pressure fuel is going to be accumulated, or it is going to act as a reservoir. On this rail, also we have a different sensor at both end that you can see here at the 5 and the 7. One of the sensor is a pressure sensor that will give you the what is the pressure inside this common rail, and the 7 is kind of we can say it is a what is called a pressure regulator valve. Pressure regulator valve sensor, we can say. So on the rail, we have a two sensor. That is, one, it measures the pressure, that actual what is the pressure inside this rail, and suppose, and 7 is the pressure controller valve. 3 is your injector, common rail direct injection CRDI injector, and 2 is the high pressure pipeline that connects rail to the injector. So these are the hardwares. So hardwares, in terms of the hardwares, we need a small fuel tank, obviously, for the fuel tank, a small fuel pump, then fuel filter, high pressure fuel pump, common rail, and the injector, and the different sensors and its control technology. These are the hardwares. Now, let us see here in a very schematic diagram of this system. All these pictures, what I'm showing here, I have taken it from the Diesel Engine Management, okay, book that is written by the Robert Bosch. It is very one chapter. I would say all of you to please go through that about the CRDI system. After this class discussions, I hope it will be very easy for you to just read it in a little bit more in details. Okay, there is nothing, any graph or no, it's a kind of the mathematical derivations or all sort of the things. This is very, as I've told several times, it is very like a novel kind of the things. And I would suggest all of you to please at least read one chapter, that is fuel injection system of that book. Hardly there will be 10 or 12 pages. Okay. Now see, this is the complete schematic of the common rail direct injection systems in the diesel engine. 3 is you have a fuel rail. Sorry, what I'm saying. It is a tank. 4 is a small fuel pump. That is, fuel is pressurized at from here. It is going to the fuel filter, and after these filtrations, the fuel is going to the high pressure fuel pump. 1 is the high pressure fuel pump, and then fuel is going to be compressed at very high pressure, and then high pressure fuel, that is, you can see here, it is going to the rail. On the rail, there are several outlets depending upon the number of the cylinder, and then from these outlets there is another fuel line pipe that connects rail to your injector. On the rail itself, we have a sensors, that is 6, that is fuel pressure sensor, and 8 is the fuel control valve. Now there might be possible that not all the fuel that is being sent from the fuel pump to the high pressure, from the tank to the high pressure fuel pump is going to be compressed and send it to the rail. There will be some amount of the fuel can go, it can return back also. So that is what it is going, the fuel return line. What I'm saying here is a fuel control valve. So it means I will explain a little bit that the fuel also can come out from here. It also, so there will be two sources of the fuel return lines, one from the fuel rail and another from the fuel pump, and these are the return lines, and then finally it goes to the your fuel tank. So this is what the schematically it is showing, that the flow of the fuel line. It is darkened. The darkened part it is showing it is a high pressure, and these are the light color that is showing the low pressure. Now let us see that what are the flexibility we have. Okay, how the fuel CRDI system controls the fuel pressure and all sort of the flexibility. In the last class, we discussed about the flexibility of the CRDI system, or even so many classes I have also discussed about that. That with the advanced fuel injection system in the diesel engine like CRDI, we have so much flexibility, or we have so much options we can play with that. For example, one is that we can vary the fuel injection pressure. Okay, we can optimize the fuel injection pressure. The first thing, fuel injection pressure, we can vary it from the 200 bar to around maximum fuel injection pressure that your CRDI system has capability. In terms of, we can say the nowadays almost all the CRDI system has a maximum fuel injection system around 1500 bar or even more than that. So in general, we can make a statement that fuel injection pressure can vary from 200 bar to 1500 bar or even more than that. So what should be the fuel injection pressure? It can be optimized for a given operating condition of the engine. That is the first important thing. You can note it down. The second thing is that when we have to inject, fuel injection timing, SOI, start of the injection, that can be also a variable parameters depending on the operating condition of the engine. At a given operating condition, SOI, start of the injections, can take place 10 degree before top dead center, or in other conditions 5 degree before top dead center, or even 20 degree before top dead center. It depends upon your optimizations with respect to a given output or given reference. The way some of the more 2/3 of the students class has done at least the experiments with the spark optimization. What should be the spark timing so that we can get the maximum output? The similar analogy is here. What should be the start of the injection so that we can get the maximum power output with the minimum emissions? So the second flexibility that what we have here, that we can vary the injection timing, the fuel injection pressure, fuel injection timing. The third variation, it is also a very important flexibility that we have, is the multiple fuel injection system in one cycle. Multiple fuel injection in one cycle. We can have 3, 2, 5, depending upon the capability of our control systems and the hardware response of your CRDI system. Accordingly, we can have multiple fuel injection system in one cycle. As I told that our one of the major objective in common rail direct in the diesel engines to improve the homogeneity. What we can do in order to improve the homogeneity, that if your system has a flexibility to do the multiple injection in one cycle, Then what we can do during the compression stroke, in the beginning of the compression stroke, a part of the fuel can be injected, and then that part of the fuel has enough time to mix with the air, okay, and forms a air fuel mixtures, but obviously it will be the out of the combustion limit. And then main fuel injection system towards the end of compression strokes can take place. In that way, there might be possibility that we can improve the homogeneity. Okay, instead of the one fuel injection system, one fuel injection process, we may have even two also, or three also, depending upon the whether your system can support such kind of the system or not. So whatever we are injecting the fuel before the main injections, that is whatever the fuel injection taking place at the towards the end of compression stroke, that we call main injection. Before that, in the compression stroke, whatever the fuel injections is process is taking place, that we called pre-injection. Pre-injection, it means it is taking place before the main injections, and the post injections, as its name suggests, after the main injections are in the expansion stroke. So we may have one or two pre-injection, one main injection, or one post injections. It depends upon the flexibility or capability of the hardware, and whether do we really need during our optimization. So these three variables adds a lot of value, and it changed the face of the diesel engine. That very high fuel injection pressure that can vary, fuel injection timing, and the multiple injection. Now, yeah, at least we have some time, we can discuss. One of the things you may have probably in mind, that how we can vary the fuel injection pressure. Okay, how we can vary the fuel injection process, what is the logic and behind that. But before going that, ideally if I can start, then probably I can compress too much, and then we don't have a time to even take one or two questions. But at this point itself, do you have any question? Any questions related with CRDI systems, general overview, whatever we have discussed here till now? Before I'm going to explain it, that how to control the fuel injection pressure, or how we can have a multiple injections, or how we have a fuel injection variable fuel injection timing. Oh, I just forget about that. We can change the fuel quantity also. Obviously, yes, we can minimize the fuel injection fuel quantity. So fuel injection pressure, fuel injection timing, fuel quantity, multiple injection. Yes. You may ask some other
The question is,
yeah, please.
spray parameters.
Yeah, please ask.
Uh, does the droplet size distribution vary with the streamline of the fuel?
Asking that the fuel injection droplet size can vary from here, something like that?
Yes, sir.
Yes, it can, because it when you are injecting inside this here, okay, it is traveling, it is going interacting with the atmosphere or in the environment in which you are injecting it. Okay, so obviously that's I'm saying that it will vary. The droplet size distributions will vary depending upon the cross sections at which you are measuring, and even it will vary at the same cross sections with the radial distance, it will also vary. Droplet size, it will be vary. It is because of the environment in which it is going to. The reason is that the fuel droplet that is present here. Okay, if you look the air fuel ratio distributions inside this jet also, at the surface the air fuel ratio, it might be in the combustible range. As you go inside this jet, the air fuel ratio along the axis is very rich, because there the air entrainment is very less. So since it is going to entrant with the air and it is going to uh, um, uh, uh, interact with the high pressure and temperature conditions, the droplet size is going to be changes. So yes, it is a variable parameters as per the cross sections, and even at the same cross sections along the radial directions, the droplet size is going to be vary. Even with this high since this advent of high pressure fuel injection system, nowadays whatever we are following the emission norms, it is so stringent that it puts the question mark on the diesel engine futures. That because company, there is a several technology, is a ready-made technology we have that can fulfill the emission norms, but the cost is also associated with that. So when you will do the business, obviously the cost is the most important thing. So that is really that's the reason probably you have probably heard the news that the Maruti has completely stopped the manufacturing of diesel engine. Because if they will satisfy the current emission norms that we'll discuss in our emission chapter, then it is not going to be cost beneficial. So Maruti has completely stopped the diesel car production. Emissions is very, very challenging part. So there are a lot of things. Any further questions till now?
So is it possible to vary the cross section of the orifice for the injector?
That is the optimization. Okay, but once you optimized for the engine, obviously it is not going to be variable parameters during the operation of the engine. It is a fixed parameter, but before that you can optimize. Yes, but you need to have obviously it is you need to optimize it. Okay, for a given engine, but for an engine it is a fixed parameter. The orifice size is approximately around 0.3 mm, or you can say that 0.25 to around 4 or 0.5 mm. But for a given engine, it is a fixed parameter. Obviously, you cannot change the injector during the running conditions.
And sir, in PFI, we had like the fuel directed at the backside of the valve, like the valve is hot for better evaporation. So is there like something similar in GDI or CRDI where fuel is directed towards maybe the hot walls of the cylinder liners to help in the evaporation?
No. In the CRDI system, that responsibility falls on the head of the automation. And then then if you correlate go back, then it is the responsibility of the fuel injection pressure, because at the high pressure the fuel droplet size will be very less, surface to volume ratio is very high, it will go it can evaporate very fast. And then once the combustion start, okay, in the diesel engine particularly, once the combustion starts, then still the fuel will study a little bit about in the combustion of the diesel engine. The fuel is still coming in to the combustion chamber. So at that time, the environment is very pressure and temperature is very high. So as soon as the fuel comes into the combustion chamber, it will go into the combustion stage. So But during the beginning of the combustion, it is the responsibility of the fuel injection presses to get evaporation at fastest possible. Okay, anything else?
So why don't we use CRDI for gasoline?
uh, Always, I have used two terms very frequently: homogeneous and heterogeneous. GDI is very much similar to the what we are talking about, the diesel engine. Okay. One of the major pollutant from the engine, whether it is SI or CI, is the particulate emission. Will come later on, but at this point we have a time I can just give introduced. And particulate emission is related with incomplete combustion or heterogeneous combustion. There's another emissions, that is the NOx emission. Both these two emissions has opposite nature. As your fuel is going to, so that's the most things is that we need to satisfy the emission norms at any cost. So that's why it's very difficult to just change the systems from here to there. You need to fulfill all sort of the parameters for research work. Yes. So as far as Nirbhay, as you are asking, yes, very much similar to the CRDI system. Now it is evolving the your what is called GDI stratified combustion. Anything else? All of you, I would request to at least go through only one chapter from gasoline engine management and diesel engine management book that is related with fuel injection system. That's all. It's very small pages, and believe me, if you have a little bit interest in the automobile, you will love it to read that part. Any questions? Okay, so if not, then let us close the session here and see you on Monday.